There we go. Okay. So this question I was asked in an interview before. I won't say by what company. But yeah, so essentially you're given an array of pairs, and these are going to be integers, positive integers. It doesn't matter if it's negative integers or not. So essentially these are just a pair of integers, and you want to group these pairs by the following rule. So you have 1 and 8, so they belong in the same group. Okay, so every pair belongs to the same group. And when there's a number that's within this group that's been seen before, any number in that pair also belongs to that group. So what that means is like, so let's say for the example we're going to iterate it this way. So we're gonna return an array of groups. So groups can be arbitrarily long. It's going to be at least 2 integers in a group. So group 1 is going to be 1 and 8. And then we go to the next one, and then there's a new group, or a seemingly new group, 2 and 3. And here, 1 and 5. But since we already see 1 here, we're going to add 5 into this group. Add that there, and then that might not be finished yet. 16 and 17 are going to be in their own group. And so we see 2 and 6. We've seen 2 before. So now we're going to say 6 is in this group. 8 and 9. 8 we saw in this group. So we're going to add 9 in this group. So these are 3 groups. And then we're going to return this. This is going to represent the different groups. So this was a pretty interesting problem. The first thought that I had was to create kind of a graph. I thought this was a graph problem, and that's actually what I'm gonna do. I was thinking about it a little bit, and I couldn't really find another way to do it. There probably is another way to do it, but yeah. So I haven't done this problem in a while, so it might be good to just kind of see my workflow for how this is done. So essentially what I wanted to try and do was create a graph of nodes. And so we could do this. So we have node 1. So every integer we see, we're going to create a node for. And if it's repeated, we're not going to create it again. Right, so 1, 8, 2, 3, 5, 16. Well, we know 16 and 17 are in their own groups. I'm just going to draw them somewhere else. Make it easier. 16 and 17. This, 2, 6, 8, and 9. Right, so now I'm going to draw an edge from 1 to 8. And it goes both ways. I forget the word for that. 2 and 3. 1 and 5. So interesting here, 1 and 5, we created a grouping of these 3 numbers as a group. 16 and 17, 2 and 6, 8 and 9. Right, so what does that give us? It gives us the groupings that I mentioned before, right? 8 is connected to 1, 1, 8, and 5 is connected. 2, 3, and 6 are connected. Wait, am I missing one? I thought there was one more number here. 1, 8, 5, and 6. No. 1, 8, 5, and 9. Yeah, 9. 2, 3, 6, and then 16, 17. So I was like, okay, I have this graph, and how am I going to create this graph? And I remember doing a problem related to topological sort back in the day, and when I created a graph that kind of actually looked like this, you could just use a dictionary, and so that's kind of what I'm going to do. So essentially what we want to do is, as we iterate through each pair, like we can go for x, y, x being the first value, y being the second value, we could create a a connection. So we could do like for pair in pairs, this being the pairs array. So pair would be each one of these. XY is equal to first item, oops, and then the second item, pair of 1. So we need to define some sort of dictionary that represents our graph. And we could do that by again using, or not again, this is from the last video, we can import default dict and have it initialized to a list as the value, default value. So we'll say D is equal to default dict, or we'll call it G, because this is our graph of list. Right, so we have XY, which is going to be, in this case, 1 and 8. We'll say G of X dot append Y, G of Y dot append X. This is an X and a Y, and then a Y and X. Right, so what does that give us? So when we go through this iteration, we have our dictionary here, and we're saying, it's like key 1, we want to append 8, right? And then also at key 8, we want to append 1. So we have this. At key 2, we want to append 3. At key 3, we want to append 2. At key 1, we want to append 5. At key 5, we want to append 1. At key 16, we want to append 17. And then at key 17, we want to append 16. And we know that these are the last elements. At key 2, we want to append 6. At key 6, we want to append 2. At key 8, we want to append 9. We can close these out now, because we're at our last element. And then at key 9, we want to append 8. So now we have this graph, and at each key we can see that we can see which ones are directly connected to whatever key. So this kind of represents this in a way, but there's a problem here, because when we look at 1, we see that it's directly connected to 8 and directly connected to 5, but we don't have the reference to 9 here. So a workaround to this would be to start from here, and for each child, I guess, or each neighbor, we have to iterate through the neighbor's values as well. We go here, we see 1, we add 1 to our current grouping. We see 8, we add 8 to our current grouping. We look at 8's children. 1 is already in the grouping, so we can ignore that. 9 is not in the grouping, so we can add 9. We have to look at 9's children as 8, but 8's already in there, so we can ignore that. And then we see 5 is there, and then that would be one grouping. But going through all these things would take time. We need to keep track of like a visited set, so that we don't just continuously loop. Because if we go to 8, go to 1, we'll go to 1, we'll go to 8 again, and then it'll just continuously loop. So let's think about how we can overcome that. Making sure it's recording. Yeah, so I'm going to delete this here, and I'm going to delete this, erase this too, so we can work with the graph that we created here. So let's say now this problem is a little bit simplified now that we have this. And yeah, so let's see how we can do this. So we can potentially maintain like a visited set of the visited nodes that we have. That could work. So let's see. define get groups, right? And then we have some graph. Is this? Let's see. We're only visiting certain node once, right? Yeah, I think it does make sense to keep track of a visited set. Call it visited is equal to a set. And let's go through, let's see, so if we go to KV in graph, the items, no, yes, we need to return this as well, right? So we need to, let's create res is equal to this. And we need to populate that result, okay? For each one, we have to populate it with something, so we have to create something that we're going to put it into, right? So the new res is equal to this first. And we'll say if not, the key is not visited, and say we need to add into the visited, add k, and then we also should put it into our new res, res.append k. Now we want to iterate through our values. Right? So if we iterate through our values, let's see. Going through our values, so I was going to do for values as an array. So for v1 in v, if not v1 in visited, add it onto our new array. So what if we actually turn this into a set? So we turn this into a set, right? And we start here, we add 1 into our set. Add 1, look at 8, we add 8. We add all of 8's children to our set, if it's not visited. But we need to check all of these values as keys as well. Let's see. So what if we just, okay, let's go with a different approach. Right. So I need to maintain these nodes and maybe use them as like a queue. Right, so we'll say nodes equals graph dot keys. Right, so that node has every unique node. And then we can use that as a queue, right? So while nodes so we're going to pop this one, and then every value we're going to add it into our new array. So when we pop 1, we want 1, 8, and 5. And then we would just be done with that. So this would be our set. And then when we go to 8, we would check if 8 exists in our current result, which it does in here. So when we finish here, we would get the set that would have this, and then append it into our results. So our current results would be an array of one set with 1, 8, and 5. And what we could do is iterate through results and check if 8 exists in the results, which it does. We can iterate through it. Then we can remove, or we can just append everything, the key and the value, into here. This would be results at index 0, right? We can go through the indices. If res of 0 has key or value, res 0 dot add each of the current. And then we would pop this from the queue. So we would now have this. Go to the next one. None of these values has 2 in them. So we would add 2, 3, and 6. We would continue. We would see 3. 3 is in this one. We would pop everything in there into the set, but since it's all in there already, we'll do nothing. 5 and 1, same thing. 16, 17. So yeah, that works, but it seems slow. Because you'd have to go through each one, and you'd have to actually check every single number each time. I think that was the same problem I had when I first did this. It was a slow runtime, n squared. But since it works, I think we should try and do that, and then if we can come up with something better, we can try and do that. Yeah, so while nodes, cur node, this is equal to nodes.pop. Pop from top. Okay, so now cur node is just 1, right? Cur node, if not cur node, in visited, I'm just going to write v.add cur node, add cur node, and then cur set equals set, cur set dot add cur node. For v in graph of cur node, if not v in visited, I'm writing v and then visited here. Visited.add v, because I have v there. Okay. Yeah, visited.add v, and then cur set add v as well. Right, so what does that give us? So we have visited set, we have some set, cur node, just going through the nodes, we get 1 first. 1 is not invisited. Add 1 to visited. Cur set. Another set. We're adding that to the cur set. For v in graph of 1, 8 and 5. If not 8 and visited. If not, we'll add it to visited. If not v in visited, we'll add it also to the cur set. And then we will add do the same for 5. So I think there's a problem here. Right, so maybe we actually don't need to maintain a visited set. Huh. The problem is, since we're putting it into visited, we're popping the first one, we're going to the next, so we're at node 8. 8 is cur node, if not cur node invisited, 8 is invisited. But we still need to get it. Oh wait, no. I think I just accidentally, I did this and it accidentally works, I think. So let's see, so visited 8 and 5. So we actually do ignore this. Okay, let's see. So this is our first iteration, cur set, and then we're doing popping into it. Cur set is this, and then we need to put it into the groupings, right? So we still need to have this results. Well, nodes. Oh. So we pop here, we have this. If not, cur node invisited. So if we just did, if not cur node invisited, then we did results dot append cur set. Right, so we'll have results is equal to this 1, 8, and 5. We'll go to the next iteration. Cur node is 8. If not cur node invisited, cur node is invisited, we skip it. We go to 2. If not cur node invisited, 2, 3, and 6. Then we create a new cur set. 2, 3, and 6 are all not visited, so we'll add all that to visited. 2, 3, and 6. And 2, 3, and 6. Results would have 2, 3, and 6. Cur set. 3 is visited, so we can skip that. 5 is visited, so we skip that. 16 and 17 not visited. So we'll add 16 and 17 into our visited. This would be 16 and 17. We would add 16 and 17 here. 6 is visited. 9 is not visited. So if not cur node invisited, so we need to add something here, right? Because 9 is not visited. We don't want 9 to be by itself. That's what it would do right here. So we can add a check here. If not current visited, here, right? We can do for I in range length of results. If cur node in res sub I dot add kernode. And then if we were to hit this, we want to continue, which would break us out of this loop. I believe it's continue, or is it? And they should only exist in our results once, right? So I believe it's continue. Break would just break us out of this for loop. Res. Give kernode in it. Then we add it into this one, right? Because 9. No. What am I saying? Right, so kernode is not in any of these. What I need to do is check F8. 8 is not in visited, so we skip. Or 8 isn't visited here, so we skip it. We go all the way down to 9. And we need to check if this 8 isn't visited. Huh. So instead of if kernode, we need to instead loop through here. So let's give myself a little bit more space. And we will do, and I still don't know if this is correct, but let's see. So for I in range of length of res, so we're looping through res, and then we need to loop through these values for vcur in graph kernode. If vcur in res of I, vcur, which is 8 in I, then we add kernode into here. And then continue, which would mean we go on to the next iteration. I need to make sure that that's syntax, or that continue works. So 2-minute pause. I'm not going to pause the video because I don't know how. Let's see. Shell. Right, so if I is equal to j, we're adding and then continuing out into the next iteration where the while loop is. that test failed. Yeah, I think it works. If it's not continue, I have to do some other check. Like, so if we're here, not current visited, I guess we could do like just the flag. We could say like, it's checking if it's in there. We'll just do like v flag equals false. And then we could do like while v flag, well not v flag, and then here we could just set it to true. And then since it would be now true, it wouldn't go through this again. Oh no, and then we'd still have the problem here. So we could do like while, well, we set this to true. We'll only do the following lines of code here if it's false. Alright, so we have v flag is false, and then now that we added something it's true, we go here in the curset.add and curset, and we say if not v flag, then we do this. Yeah, that works. And then at the end, we would just return results. So this is kind of running like O of n squared time. But I think this is kind of one of the more important parts. And then this kind of logic, I think you can. There's different ways to implement it. It's definitely not the way I did it the first time, but I think it's kind of similar. I'll check my notes and do it again. But yeah, and then res out of pen, curset, and then at the end you would just, outside of this while loop, you would return res. So yeah, I mean, it's going to go over some codes. I'm just not going to write it. That's the general gist. Coolio.